Greetings, Statesman. We're going to start lesson 1.3, which is regarding midpoint and distance. First thing we're going to do is we're going to start with doing some definition. So a midpoint, when we're discussing this mathematically, a midpoint is a point that divides a segment into two congruent parts. So when we're going to see, for example, and it's going to be congruent because we're going to mark it that way. Remember how we're going to do that, and we had discussed this in class. So let's say that I have on a line segment, and this is fairly straight, but not as straight as it can be. But it's assumed that it's a line segment. This line, or this point B, happens on line segment AC. And the way that we're going to mark this guy congruent is that we're going to have these single tick marks here, right? And meaning congruent, and shown this way, right? When I say that segment AB is going to be congruent to segment BC. Now, we discussed in class, we're missing these line segments on top of the 2 points of the 2 capital letters, and that is permissible. We're allowed to do that, and that's just what's done. Now, next, which is construction we're going to do in class, which is when we have the segment bisector. And what the segment bisector is the point, ray, line segment, or even a plane that intersects a line at the midpoint, okay? So in this case, that segment bisector is what we had described before. It's this point B. I could also put something, right, that slashes through here on line segment AC. As long as it cuts that in half, exactly in half, into 2 congruent parts, 2 equal measurements, then it is the segment bisector. Bisector, this word right here, make sure that we're using it very intentionally. It doesn't mean that it's just cut into 2 pieces. It means cut into 2 equal pieces. All right. Says my pen battery's low, which means I maybe have this thing die on me mid lecture, but I'll gotta resolve that because I've seen me struggle with that in class. The next thing we're going to talk about is absolute value, which I described actually to many of you guys in class, which is the distance from 0. All right, I didn't know this. This is again a confession I made to you guys. I didn't know this concept technically till grad school. Whenever I would see this, for example, I would see negative absolute value of -6, and I would just know, oh, that's just going to be +6, right? You just always make the value positive. And if I added that to the absolute value of 2, well, 2 is already positive. Keep it as 2. So effectively, this is 6 plus 2, which is 8. Okay? Effectively, what I get there when I do that is I have the distance between -6 and 2. All right? Now, next thing that we're going to do here. We're going to derive a formula here, and it's going to use some other concepts that you guys have learned previously, and then we're going to employ the midpoint formula, but we're going to do distance first, okay? And this is rather formulaic, and I do need to show you guys this as to why this works this way, because again, we're not just in this mode of trust me, bro. We're actually trying to be men of reason and deductively prove something to be true. So I'm going to use a couple formulas that you guys learned in Algebra 1 to derive this distance formula. So what we're going to do here is I'm going to plot 3 coordinates on the coordinate plane. Oops. Oh, what happened there? Ooh, goodness gracious, I'm snipping stuff. There we go. Okay. Back to what I was doing. All right. That was weird. I have these 3 points, which are A, which is at the origin, 0, 0. I have another point up here, which we're going to call B, which is at 4, right? Because this is X, Y. So 4, 3. And then randomly I have C, which is going to be on the y-axis, on the x-axis, which is 4, 0. All right. Now, this of course makes a triangle, right? I could actually sit here and I could plot these points, and this is going to be a right triangle. So we're going to be able to utilize the Pythagorean theorem. Now, one thing I'm going to show you guys, this is a notation thing I hope you guys remember in the and then later on we discuss triangles, but this line opposite, that is line segment AB, this guy's opposite this coordinate C. So we're going to use a lowercase c to denote the side. So this is lowercase c, okay? And then again, I have BC right here, line segment BC, which I'm going to call lowercase a, right? Because it's opposite A, right? It's opposite. That's what I mean by opposite. And then I'm going to have AC, right? This on the x-axis, which is going to be lowercase b. All right? So stay with me here. Now remember, I have a couple distances here. And we could actually figure this out because I have this one right here, which is this rise, which is where we're going to go up, right? And that distance, you guys, with that counting principle we just discussed in the last class, we just measure that by counting on the number line, and that's going to be a 3. And then, of course, here, this is that thing mathematically referred to as the run, right? Which is where this is going to be equal to 4, okay? So where we have the slope, which is m, mathematically, it's the variable that's that was decided mathematicians would use rather than s, because s is a little confusing. It looks like the number 5, for example. Remember, you learned that this is rise over run, which is your vertical change over your horizontal change. In this case, this guy is 3 over 4. Now, remember, you can also calculate that from the change in y, right? That's the vertical change over the horizontal change, the change in x, okay? So you can probably remember the slope formula right here. And that's what this top rise really is. That 3 really is this, okay? Now, I want you guys to think about this. I have a right triangle, meaning that I can employ the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So this is something you probably have from prior knowledge from your pre-algebra class that you took probably actually around 7th grade. It's a middle school standard, okay? So a squared plus b squared is c squared, okay? Now, one of the things I want us to do, though, is that we have a, and a is this guy, the rise, okay? Which is going to be 3 eventually. But remember, I have rise right here, which really is the 3, but also it's y sub 2, okay? Minus y sub 1 squared. Now, what this means, I discussed this in one of your classes where I had, we were discussing subscripts. This is like if we have like two guys named Juan in the class, right? We'd have we could just decide one of them is the first one is the second one, right? Usually you would go and utilize the last initial. That's usually the common solution that teachers have. You kind of start in elementary school, right? There'd be one G and then one F, right? But instead, we're going to just say it's the first one, the second one. So these have the subscript has no mathematical function. This does not mean to the second power, just as mean it's the second y, okay? And that's what we can go back here, and we can name all these coordinates, right? Where we could say this is x sub 1, and this is x sub 2, right? And we're going to talk, or y sub 1, right? Sorry, because it's comma y. And we'll do that actually when we expound more on the slope in the future. But for now, I'm just trying to show you guys the replacement here. So we have the run, right? Which this is opposite b, so this is going to be lowercase b, all right? And since it's the run is this bottom portion, x sub 2 minus x sub 1. And that's squared. And of course, that's going to be my c squared. Now, if I'm going to solve for c, I'm going to have to take a square root on both sides, right? So it's my square root. Okay. So this entire thing right here. Okay. And if I do that, then this entire left side, square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. All this is under the square root sign, and the square root of c squared is just plainly c, okay? So this is our distance formula. The distance formula is equal to the difference of the y's squared plus the difference of the x's squared. Now, This is a rather forgiving formula. You need to memorize this formula. You will need to do this for your next quiz, which is for blocks 1, 3, and 5. Is in just a couple days, and then in midweek it'll be for blocks 4 and 6. So something for you guys to think about. You need to memorize this formula. We're gonna utilize this formula quite a bit. Now, I want you guys to think about this. You guys know the Pythagorean theorem, right? Which was a squared plus b squared was equal to c squared. I just want to verify and show you guys something. Well, let's go back here. My a, b, and c that I had, my Pythagorean theorem, right? My a over here was 3, and my b over here is 4. So 3 squared plus 4 squared was equal to c squared, which is going to be 9 plus 16 is c squared. 9 plus 16 is 25 is equal to c squared. And to solve for c, I have to take square root on both sides. Square root of 25 is 5, and that's my c. Okay? Now, think about this. If I wanted to find c, right, and I had my coordinates, I have 0, 0, right? Let's go back up here. I had 0, 0, b is 4, 3, and c is 4, 0. C is 4, 0. Okay? Now, I already know my distances for A and B, right? I just have to be able to count on the number line. But the issue is, what is AB? Which really means that we're going to find, our hint is it equals C. Okay? So in other words, we're going to do our distance formula here. This is my x sub 1. This is my y sub 1. This is my x sub 2. This is my y sub 2. Okay? And then let's utilize the distance formula. So in the square root of 3 minus 0 squared, right? 3 minus 0, y sub 2 minus y sub 1. And then plus x sub 2 minus x sub 1. So 4 minus 0 squared. And look at what we're going to get, guys. We're already on our way here. You guys can see it, I think. This is what we just had, right? The square root of 9 squared plus 4 squared. Excuse me, 9 squared. 3 squared, boo. Already getting ahead of myself. Or 9 plus 16, which is going to be the square root of 25, which we know, of course, is 5. So it's the same exact thing. This is kind of just a verification showing that our distance formula works. Okay? Now, let's do a problem. We're not going to get a graph. We're just going to find the distance. Between A, which is negative 5, comma 2, and B, I'm sorry, let's do a different variable, and D, which is 1, comma 4. Okay? Now let's do our distance formula. D is equal to the big square root, right? And I'm going to show you guys something here. I can actually switch up my formula. It's going to work out for me, okay? Here's why. When we take the difference of the y's and the difference of the x's, we want to be consistent. Now, this is why this formula is forgiving. As you guys learned, when you learned about slope, you can't freestyle. You can't just decide 1 and 2 go in whatever order that you want, right? So, why this winds up being fairly forgiving is because we wind up squaring the term anyway, right? So if we took a difference and we got 3, I want you guys to take a look at what we're going to do here, for example. So let's label these guys. This is I think, a key to these problems. So big square root. If I take negative 5 and I subtract 1 and I square it. Oh, I'm sorry, that's the x's, but that's the x's. Let's do the y's. By the way, it won't matter because of the commutative property, what order we go in here. Okay? So I'm sorry, we're going to go 2 minus 4 squared. Okay? Now think about this. 2 minus 4 is equal to negative 2. And 4 minus 2 is equal to 2. Pretty sloppy over here, guys. Okay? But if you square both of these, negative 2 squared is going to be equal to 4. And then if I take 2 squared, it's equal to 4. So because I square it, it's going to come out with the same, effectively, the same value anyway. All right? So then let's get back to our problem here and just finish up. X. I have a negative 5 and I have minus 1 squared. Okay? So then, continuing on, I have a negative 2 squared plus negative 6 squared, which means I'm going to have to take the square root of 4 plus 36, okay? Which is going to give me rad 40, okay? Now, if you guys were to do this, we're going to have an issue because we need to make sure that we reduce this guy, all right? We're going to look inside of 40 and reduce to a perfect square. So it's going to be 4 times 10, okay? Square root of 4 is 2, and this will be 2 rad 10, okay? Now, for your first lessons, if we leave it this way, then we're going to be okay. Do not put this into a calculator and give me, we're going to talk about this more in class. We do not want the decimal approximation. Okay? I don't want you guys to tell me what rad 40 is, right? 6.2 3 or whatever it is. I don't really care. And I'll show you guys why. I want the exact answer, which is just rad 40, and more specifically 2 rad 10. After the first quiz, the rad 40 by itself without being reduced will get a deduction. But if you guys can get the distance formula as is, I'm going to be pretty happy about it. Now, let's get to the midpoint formula, okay? So, midpoint formula. We're going to take the average of the x's, and that's going to be comma the average of the y's. Now, that seems like a really funny thing to say because the average of two things, right, means that we're going to divide by 2. So in other words, we're going to say x sub 1 plus x sub 2, and we'll divide by 2, okay, comma, y sub 1 plus y sub 2, and divide by 2. All right, you have to, guess what? Memorize this formula. In class, we're going to be able to use our notes. On your quiz, you will not. Okay, so we're going to go back. Use the same exact premise here. And now we're going to find the midpoint. For xy, if, and we're going to call these guys, oops, x, and the name of the other coordinate is going to be y. Now, gentlemen, it's the same exact coordinates I used before. Now we just got to use these, okay? So here we go. It is going to be, again, x sub 1, y sub 1, x sub 2, y sub 2. So we just plug and play here, okay? I have negative 5 plus 1, and that's going to be over 2, comma, 2 plus 4, right? Y sub 1 plus y sub 2, all over 2. Which I have negative 5 plus 1 is negative 4 over 2, comma 2 plus 4 is 6 over 2, and of course negative 4 over 2 is negative 2, comma 3. And that is my midpoint, okay? That's the answer. Next, we're going to find the midpoint of, we're going to find D if E is the midpoint of DF and E is negative 4, comma 3, and F is negative 3, comma 5. Okay. I'm sorry. This guy should be negative 2, and this guy should be 7. I messed up my direction. Okay? Make sure you guys get this down here. Now, here's what we do. I have a line segment. I'm going to show you guys how we do this, and then I'm going to show you a better way in class. I have D, I have E, and I have F, okay? This is what I'm searching for. In other words, I need to find my X comma Y. But what I was given is my midpoint, which is negative 4, 3. So this is the answer. From using the formula. And then the F is negative 2 comma 7. All right? So if E is the midpoint, so my thing is I'm finding E, and I have this X sub 1 plus X sub 2 over 2, comma, Y sub 1 plus Y sub 2 over 2. Okay? But the thing is that E I already have. So I'm going to effectively do two problems here, okay? So I have my X, which is already negative 4, and that's equal to this, my X sub 1 right here, right? Plus this, negative 2. And that's over 2. All right? And then I have my answer here for this guy. So I'm going to have my 3, which is equal to, right, this entire thing. So that's the Y plus my Y sub 2, which is the 7 over 2. All right? And now I have to solve two different problems. To solve this, I have to multiply by 2 on both sides. Cancels, cancels. 2 times negative 4 is negative 8, which is equal to X plus negative 2 is X minus 2 plus 2 plus 2. And negative 6 is equal to X. Okay? Over here, multiply by 2 on both sides. 2 times 3 is 6, which is equal to, this guy cancels, so I'm going to have Y plus 7, minus 7, minus 7, and negative 1 is equal to Y. So my coordinate for D is negative 6, comma, negative 1. All right? And there we go. So that's it. I'll see you guys in class. Big lesson. And we'll do a lot of practice in class. This problem, I'm going to show you guys a shortcut when we get to class. Okay? Good luck.